And the fact of the matter is, when a ball is rolled up a ramp, its velocity will be decreasing continually. Whether the ball is on the ramp on its way up or still on the ramp on its way down, the velocity might go from positive 10 to positive 5 to 0 to negative 5 to negative 10. And from 10 to 5 is a decrease. From 5 to 0 is a decrease. From 0 to negative 5 is a decrease. From negative 5 to negative 10 is a decrease. So this acceleration will be negative. Remember that compared to the quiz that you wrote, we need to be aware that these quantities are vectors. Well, those quantities are vectors, and then of course time is a scalar. How many of you have gotten more comfortable with these types of situations where you find yourself not necessarily writing out a list of things? No? One or two maybe. You might get there. So VI, the ball is rolled up the ramp at 6 meters per second. You know, when we say up the ramp, we know that up doesn't mean vertically up. It means up the ramp, along the ramp. After 3 seconds, it is rolling down the ramp with a speed of 2 meters per second. This question, by the way, is not a difficult question. We kind of peaked in difficulty with questions 3 and 4, and now we're back on our way down to a simpler question. How far along the ramp did it travel before turning around? So, this is not necessarily a simple question. I mean, I don't think it's as complicated as the previous ones, but what we have is a ball, and the ball is initially rolling up the ramp. I think a diagram will be useful here. At 6 meters per second. Some point later, it has traveled up and now it's on its way back down. And it's traveling down at 2 meters per second. So this is a different point in time. I mean, you guys are smart. You know I shouldn't have to tell you this, but I'm going to say it anyway. There are not 2 balls on the ramp, right? This is just showing the ball at different points in time. But what does the question ask? The question asks, how far along the ramp does the ball travel before turning around? Well, that is some point up here. So all of this information here, everybody, is talking about that situation. Over here, this is something different. But there is something that is the same in both situations. What? What do you think is going to be the same, whether we talk about this or whether we talk about this? Well, I'll put my BF in. What do you think is the same? I mean, I know that the 6 meters per second is the same, but there's something else that's the same.
Acceleration.
The acceleration. Because the acceleration is determined by the fact that this is a straight ramp. Whatever it is, it is. It's a uniform acceleration. Whether it's accelerating from positive 6 meters per second to negative 2 meters per second, or whether it's accelerating from positive 6 to 0 meters per second, the accelerations will be the same. So I guess I'm going to eat my words here and say this is not necessarily a simple question. You do need to recognize that these accelerations are the same. And just one final note before we get into the number crunching. I hope you understand that this question is saying what's the maximum height? What's the maximum distance along the ramp? So what we need to do is use kinematics over here to determine the acceleration. Whatever we get for the acceleration, we're going to put in right there. And then we can use kinematics to find, I don't even have it in the list, to find d. So which kinematics equation can we use for this information over on the left? Well, Vf minus Vi over T equals A. A very straightforward calculation. So straightforward, in fact, that I don't even feel the need to write down the numbers. Are you fine with that? If you want to write down the numbers on paper, go ahead, but they're right there. The formula is already rearranged for what we want. So I'm simply going to take Vf, which is negative 2, minus Vi, which is positive 6. It's going to give us negative 8. Divided by 3 seconds, the acceleration is negative 2.6 repeating meters per second squared. Okay, well, we can put that over here. And now we can find the distance. This time is not 3 seconds. It's going to be, if you wanted to calculate it, it's got to be less than 3 seconds. Because 3 seconds is the time it takes the ball to get to the top and back down to the point where it's moving at 2 meters per second. But we're not interested in the time, we're interested in the displacement. So we can use Vf squared equals Vi squared plus 2AD. Remember, vector symbols above the A and the D, but not above the Vi and the Vf. So this will be 0 squared equals 6 squared plus 2 times negative 2.6 repeating times d. Remember, with the units, I don't want you to put in units. If you have to put in units because you're that kind of person, it's just got to be tickety-boo, perfect, put them in. I think students are more likely at this point in the course and in the year to make mistakes if they put the units in. How's my arithmetic there? 2 times 2.6 repeating is 5.3 repeating. Pretty basic equation. Add 5.3 repeating d to both sides. This is equal to 36, so now we can divide and get the answer. .75. Is that right? I'm going to surprise myself this morning. 6.75 meters. I don't care if you round to 6.8 meters. It doesn't matter. It doesn't matter at this point. Those are details we don't need to worry about. We want to worry about, can you use the formulas properly at this point in the course to get the right answer.